Welcome to Future Forward. Artificial intelligence, general intelligence, superintelligence. Today we dive deep into the ethical dilemmas shaping our digital world. Today we're tackling a complex and increasingly critical issue: bias in AI and machine learning. How do we ensure these systems are fair, equitable, and don't perpetuate existing societal prejudices? I'm your host, and I'm thrilled to be joined by a leading expert in algorithmic fairness. Welcome to the show. Thanks for having me. It's a really important conversation. It feels like every week there's a new story about AI gone wrong, reinforcing stereotypes or making discriminatory decisions. So let's dive in and paint a picture of the different ways bias can creep into AI systems. It's more insidious than many people realize. It's not just one type of bias, it's a whole spectrum. You've got historical bias, where the training data reflects past societal prejudices. Think of a hiring algorithm trained on data where leadership roles were predominantly held by one gender. That algorithm might then unfairly favour that gender for future leadership positions, perpetuating the imbalance. So you might be thinking, is AI just learning and amplifying existing inequalities? Well, exactly. Then there's representation bias, which occurs when certain groups are underrepresented in the training data. If your facial recognition system is primarily trained on images of one ethnicity, it's likely to perform poorly on others. Measurement bias is another big one. This is where the proxies we use to represent real-world phenomena are inaccurate or unfair. For instance, using zip codes as a proxy for creditworthiness can perpetuate bias against people living in lower-income areas. So even the data we choose to feed the AI can be a source of bias. And finally, we have algorithmic bias itself. This is bias that's introduced during the training or optimization process, often unintentionally. It's like a perfect storm of potential problems. Let's make this concrete with some real-world examples of where this has gone wrong. Hiring and recruitment systems are rife with examples. There have been cases where algorithms have shown gender and minority bias, unfairly disadvantaging qualified candidates. We also see it in credit and lending, with bias against certain neighbourhoods leading to unequal access to financial services. And of course, facial recognition, as we discussed, is a well-documented area of concern. Let's talk about hidden examples that people would not usually consider. Healthcare is one to watch closely. Risk models used to predict patient outcomes have been shown to misdiagnose or undervalue the needs of minority groups, leading to disparities in care. It's incredibly worrying. This is painting a pretty bleak picture. What can we do about it? Why is auditing these systems so important? Auditing is crucial for several reasons. First and foremost, it helps prevent discrimination. By identifying and mitigating bias, we can ensure that AI systems are fair and equitable. Second, it ensures regulatory compliance. As governments around the world introduce stricter regulations on AI, auditing becomes essential for avoiding legal and financial penalties. And finally, it maintains public trust. If people don't trust AI systems, they're less likely to use them, which can hinder innovation and progress. Hold on to that thought about trust for a second, because I want to return to it. I'm curious about the specific strategies for mitigating bias. Let's talk about what tools are at our disposal. There are several approaches, each with its own strengths and weaknesses. Pre-processing techniques focus on modifying the training data itself. This might involve data balancing, where you resample the data to ensure that all groups are equally represented, or it could involve techniques to remove discriminatory features from the data. Then think about during the training process itself, which is where in-processing techniques come in. These involve incorporating fairness constraints into the training algorithm. For example, you might penalise the algorithm for making predictions that are biased against a particular group. Then, of course, after the model is trained, called post-processing techniques that involve adjusting the model's outputs to improve fairness. This might involve calibrating the model's predictions so that they are equally accurate for all groups. Or it could involve setting different thresholds for different groups to achieve a desired level of fairness. As you can see, there's no silver bullet. It requires a multifaceted approach, and it often requires human oversight. Human-in-the-loop systems involve domain experts reviewing the model's decisions, particularly in high-stakes situations. This can help catch biases that might be missed by automated methods. Now let's turn to governments that are starting to regulate AI and what kind of governance structures are needed to ensure ethical AI development and deployment. It's not just about technology, it's about people, processes, and policies. We need standardized auditing practices, clear lines of accountability, and ongoing monitoring to ensure that AI systems are used responsibly. There are really big challenges in establishing effective AI governance. The complexity of bias sources is a major hurdle. As mentioned earlier, bias can creep in at various stages of the AI lifecycle, making it difficult to identify and mitigate. Resource constraints are also a factor. Auditing and mitigating bias can be time-consuming and expensive, particularly for smaller organizations. And finally, evolving fairness standards pose a challenge. What is considered fair today may not be considered fair tomorrow, as societal norms and values change. This can be an ongoing process of adaptation and refinement, which makes the adoption of standardized auditing practices even more important. It provides a baseline and a framework for continuous improvement. Crucially, we need to integrate explainability into AI systems. We need to understand why a model is making certain predictions, so we can identify and address potential biases. Explainability is key. AI shouldn't be a black box. If you can't see inside, you can't fix the problem. And of course, we need to strengthen regulation. Governments have a vital role to play in setting clear standards for AI development and deployment. We also need to invest in diverse datasets. Training data should accurately reflect the diversity of the population to avoid perpetuating bias. Earlier, I mentioned that public trust is essential for people to adopt AI. How can we build that trust, you might be asking? Transparency is crucial. People need to understand how AI systems work and how they're being used. Independent oversight is also important. We need independent bodies to audit AI systems and ensure that they're fair and equitable. And perhaps most importantly, we need to engage in open and honest conversations about the ethical implications of AI. The more people understand the risks and benefits, the more likely they are to trust AI systems. It's a tough balancing act, innovation versus regulation, progress versus protection. But it's a balance we need to strike. I recall one report that described it well. Ethical AI requires continuous auditing, fairness-aware design, transparency, and long-term governance to ensure equitable outcomes. It's not a one-time fix, but a continuous commitment. So let's zoom out for a second. We've talked a lot about the technical aspects of bias mitigation. But what about the broader societal context? How do we address the underlying prejudices that contribute to bias in the first place? Well, now that's the million-dollar question. Technology can only do so much. Ultimately, we need to address the root causes of inequality. That means challenging discriminatory attitudes and behaviours, promoting diversity and inclusion, and ensuring that everyone has equal opportunities. It also means being aware of our own biases and actively working to overcome them. It sounds like AI bias is a symptom of a much larger problem. As we start to wrap up, let's reiterate the unifying topic, that being how we ensure AI systems are fair, equitable, and don't perpetuate existing societal prejudices. And the solution isn't purely technical. It requires a combination of technical solutions, ethical frameworks, and societal change. Before I finish, I want to revisit something I mentioned earlier. The importance of public trust. What happens if we fail to address bias in AI? What are the potential consequences? The consequences could be severe. If AI systems are perceived as unfair or discriminatory, it could erode public trust in technology, leading to widespread resistance and rejection. It could also exacerbate existing inequalities, creating a society where some groups are systematically disadvantaged. And it could undermine the potential of AI to solve some of the world's most pressing problems. So the stakes are incredibly high, but I'm optimistic that we can address these challenges. By working together, we can create AI systems that are fair, equitable, and beneficial to all. So to summarize the most important insight from our deep dive, mitigating bias in AI requires a multifaceted approach that combines technical solutions with ethical considerations and societal awareness. And it requires a continuous commitment to learning, adaptation, and improvement. And here are some real-world relevance for you out there. AI is already impacting our lives in countless ways, from the news we consume to the jobs we apply for. Understanding the potential for bias is crucial for making informed decisions and advocating for a more equitable future. Thanks for tuning in to Future Forward. Artificial intelligence, general intelligence, superintelligence. Here's a final thought. As AI becomes more integrated into our lives, how can we ensure that it reflects our values and promotes a more just and equitable world? See you in the next episode. We'll be delving into AI efficiency and energy. Yes, the conundrum of energy supply for AI.